Hello everyone. In this video, I will be talking about friction and circular motion. Okay. So first we can see what we mean by friction. Friction. Okay. In this example, a toy car is pushed with a force. After some time, the toy car comes to rest. Why? Because it is acted upon by an force in the opposite direction. And this is the friction between the surface on which the toy car is moving and the wheels of the toy car. Thus, friction is a force which acts opposite to the applied force. Friction is a force that acts to stop the movement of two touching things. Two kinds of friction are static and kinetic. Static friction is when the friction is strong enough to stop movement between two objects. That is, when the body is stationary. While kinetic friction is used when the frictional force is not strong enough to stop all motion, as in the case of this toy car moving. Now, we can see what we mean by static friction. Static friction opposes impending motion. That is, the motion that would take place under applied force if the friction were absent and is denoted by Fs. It is found experimentally that the limiting value of static friction is independent of the area of contact and varies with the normal force. That is, the normal force approximately as Fs max is equal to mu s into n, where mu s is the coefficient of static friction and it varies according to the surfaces in contact. Now, if the applied force exceeds Fs max, the body begins to slide on the surface. That is, motion only takes place if the applied force exceeds this static frictional force. Now, kinetic friction. Frictional force that opposes relative motion between surfaces in contact is called kinetic or sliding friction and is denoted by Ft. Now, kinetic friction, like static friction, is found to be independent of the area of contact and is given by the formula Fk is equal to mu k into n, where n is the normal force while mu k is the coefficient of kinetic friction, which is also varies according to the surfaces in contact with each other. Now, there is another friction which is much lesser than the kinetic friction and the static friction, which is the rolling friction. It is a resistive force that slows down the motion of a rolling ball or wheel. It is also called rolling resistance. And it is given by Fr is equal to mu r into n. Since rolling friction is the least, wheel is made circular. Now, circular motion. In this diagram, we can observe a car which is going through a circular road. In this case, the acceleration experienced by this car is directed towards the center and will be given by the value acceleration A is equal to v square by r. This acceleration is known as centripetal acceleration, since the direction of acceleration is always towards the center of the circular path. Now, according to Newton's second law, the force F providing the acceleration is mv square by r, as the centripetal force is given by mv square by r. Now, there are three forces acting on a car moving in a circular path. First is the weight of the car mg acting downward. Then there is the normal reaction, and then there is the frictional force. Frictional force is the force which acts opposite to the direction in which the car is moving. That's the frictional force. Now, motion of car on level road. In this case, as shown in figure, these three forces acts as shown in figure. As there is no acceleration in the vertical direction, we can say that n minus mg is equal to 0, or n is equal to, which is the normal reaction, is equal to mg. Now the centripetal force required for circular motion is along the surface of the road. It is provided by the component of the contact force between the road and the car tires along the surface. This by definition is the frictional force. Hence we can say that frictional force has to be lesser than or equal to mu s n, which is equal to mv square by r. That means v square will be lesser than or equal to mu s into mg r by m. Here both the m's get cancelled and we get for Vmax, that is the maximum velocity with which the car can go in the circular motion, as root of mu s into rg, where mu s is the coefficient of static friction, r is the radius of the circular path, and g is the acceleration due to gravity. As shown in this formula, the speed with which the car can travel is independent of the mass of the car. Now, motion of a car on a banked road. This is when the car moves along a slant while turning. And from this formula, we can see the why it is better to bank roads in turnings, since car can traverse the turn at much higher speeds compared to the flat circular path discussed earlier. So these are the forces that are acting on the car as shown in the figure. There are normal force N, mg, the weight, and the centripetal force and the force of friction. Now the normal force, the mg force and the frictional force can be resolved into n cos theta, f sin theta, and s cos theta and n sin theta. From this, we can form the equations. That is, since the acceleration in the vertical direction is 0, we can see that n cos theta is equal to mg plus f sin theta. And similarly, the frictional force required to balance the centripetal force, we can write the second equation, which is n sin theta plus s cos theta is equal to mv square by r. So in order to obtain Vmax, which is the maximum velocity with which the car can traverse the banked road, to obtain that, we can substitute the value of force of friction as mu s n, where mu s is the coefficient of static friction and n is the normal reaction. Now substituting in this, in both the above equations, we get n cos theta is equal to mg plus mu s n sin theta, and n sin theta plus mu s n cos theta is equal to mv square by r. From equation, we can find the value of normal reaction n from equation 1. That is n is equal to mg by cos theta minus mu s sin theta. Now substituting this value in the second equation, we get mg into sin theta plus us cos theta by cos theta minus mu s sin theta. That's equal to mv max square by r. That is V max is equal to Rg into mu s plus tan theta divided by 1 minus mu s the whole root. From this formula itself, it is clear that V max will be much greater in this case compared to the case when the car was on a flat road. So this is the end of this video. In this video, I have discussed the concept of friction, then extended this concept to circular motion to find the equations for the maximum velocity with which a car can go on a flat road as well as on a banked road. If you have got any doubt in any of the topics discussed in this video, please comment in the section below. Thank you.